This is the second session in the series of videos about EMC testing. In this session, we're going to describe the techniques used for the measurement of conducted emissions. Let's assume this is our product that we're going to test. So this is our EUT. It's mains powered, so it's connected to the mains via a power cable. If we switch it on, we'll maybe get some radiated interference and maybe some conducted interference too. The aim of the exercise in this session is to measure the amount of this interference being conducted back to the mains distribution system. The easiest way to do this is to capacitively couple to the cable so that we can extract the interfering signal and send that to our analyzer. So basically we're measuring voltage. This is simple enough to do. We can do this over the frequency range as determined by the standards. The problem with this is that the impedance of the mains over this frequency range is quite unknown. It's completely uncontrolled. It will vary from place to place. Unfortunately, if this impedance varies, it means the voltage here will vary too. This is simple Ohm's law. So for example, if we have low impedance at the mains, you'll see a low voltage from the capacitive coupling, even though our EUT is delivering a consistent voltage. Similarly, if there's high impedance in the mains, we'll see a higher voltage. Clearly, this is going to lead to inconsistent results. What we do is to add in a network, which means that the impedance as seen from the EUT is consistently 50 ohms. So if we all use the same network, we'll all make the same consistent readings. So the network is specified by the standards, and we should all use these networks. The network is called a line impedance stabilization network because it does stabilize the impedance of the line. If we look in more detail at how we connect to the line, we can see that we need to connect to both live and neutral on a single phase supply. These are each measured by the analyzer. Each must comply with the limits set down by the standards. Similarly, in a three-phase supply, we have 4 connections and we measure each one in turn. So that's our LISN. One outstanding problem here, and that is that we're connected to the mains, and on the mains there is frequently quite energetic impulses coming through. Maybe the guy next door switched some lighting on or off, and that can cause these impulsive disturbances which will be transmitted through the LISN and potentially down to our analyzer and damage the analyzer. The way we avoid this is to put in a transient limiter. This blocks the impulsive noise coming in from the mains, but the downside is we have an insertion loss, possibly up to 30 dBs, which means the signal here will be 30 dBs lower than the signal on the mains cable. To look further down our measurement network, the next stage may be a filter to remove unwanted frequencies, then a preamplifier which will recover the loss caused by the transient limiter, and then to our analyzer which actually makes the measurements. This may be connected to the PC to show results and to control the whole system. Finally, the filter may be replaced by a device called a pre-selector. We'll talk about that more in a later session. So this is the setup. Now the standards define exactly how we set this up physically. They define a wooden table, or at least a non-metallic table, no ground plane on top of the table, but we do have a ground plane or horizontal reference plane on the floor. We bolt the LISN to this ground plane. It's bolted down to make sure we get good bonding to the ground plane, and the product is put onto the table, connected by a short mains cable to the LISN. the cable should be just long enough. Excessive length does not help. Finally, we take the output from the listen to our instrumentation. This is an example of how not to do it. We do not need a ground plane on the tabletop. The table should not be metallic in any way. The cable should not be excessively long, and the listen needs to be bolted to the ground plane. If we do the bonding via a bonding wire, at the frequencies of interest, this wire will present high impedance and therefore is quite unsatisfactory. In our next session, we will see how a real test is set up and how the test system is initialized.